Hello and welcome to the Maths Matrix. My name's Rebecca and in this series of videos we'll be doing fractions. It's really important at GCSE that you're able to confidently add, take, times and divide fractions without a calculator, and that you're able to convert between mixed numbers and improper fractions. So that's what we're going to focus on in this series of videos. I'm going to pop a list of questions on screen shortly, and if you're absolutely sure that you know how to do all of those questions confidently, then you don't have to watch any of the videos in this series. You can just move on to a new topic. If your fractions work is nearly there and you're looking for a quick recap or a quick revision session on how to do the different types of questions, then go to the last video in the series, which will cover each of the topics very quickly. If your fractions work is not that strong, then I'm going to do a series of videos on cancelling fractions down, adding and subtracting, timesing and dividing, and converting between mixed numbers and improper fractions, so you can watch those in order and go through the topics more slowly. So here are the questions now. All right. If you're still with me, then I'm assuming that you need to go through fractions work more slowly, so that's what we'll be doing in these videos. In this video, we're going to start with cancelling down fractions. So once again, I'm going to pop some questions on screen that are all just to do with cancelling down fractions. If you know that you could do all of them, then you don't have to watch this video. You can move on to the next one in the series, which is adding and subtracting. If you're not sure how to cancel down fractions, then stick with the video and I'll show you how. Here are the questions now. All right, so if you're still here, then I'm assuming that you're not sure how to cancel down fractions, so let's start there. So if you put a title of fractions, and then put a subtitle of cancelling down fractions. And then put, to cancel a fraction down, find a number that both the numerator and the denominator divide by. Divide both parts of the fraction by that number. If there is still a number that both top and bottom can be divided by, divide them again. Keep going until there is no number left that both the top and bottom will divide by. When you reach this point, the fraction is said to be in its simplest form or its lowest terms. And then put, e.g., express 24 over 26 as a fraction in its simplest form. And then what we do is if we have the fraction 24 over 26, each of those numbers is even. So that means that both the top number and the bottom number can be divided by 2. So if I divide the top by 2, I get 12. And if I divide the bottom by 2, I get 13. And there are no more numbers that both 12 and 13 will divide by, apart from 1, which wouldn't get you anywhere. If you divided them each by 1, you'd still end up with 12 over 13, so nothing would change. So if I divide the top and bottom by 2, I get 12 over 13, and then there's nothing else that they both divide by. So that's been cancelled down now, and it's in its simplest form. If you then express 30 over 36 as a fraction in its simplest form. Now again here, 30 and 36 are both even, so we can divide by 2 to give 15 on top, and we can divide by 2 on the bottom as well to give 18 on the bottom. But this time there is a number that goes into both 15 and 18, and that number is 3. So I can divide the top one by 3 to give 5, and I can divide the bottom one by 3 to give 6. And at that point there's no other number that will go into both 5 and 6. So the fraction is in its simplest form. Now you can make that quicker if you spot that 30 and 36 both divide by 6. So what we could have done is divided the top one by 6 to give 5 and the bottom one by 6 to give 6, which would have got us to the end answer one stage faster. So if you can find the biggest possible number that goes into both the top and bottom, you'll get your answer faster. But if you can't find a large number straight away and you want to do it in 2 stages or 3 stages or lots of stages, it's absolutely fine to do that as well. Everybody will get the same answer in the end. Show you another one. So if we have express 45 over 60 as a fraction in its lowest terms. So if we start with the 45 over 60, each of those divides by 5, because one ends in a 5 and one ends in a 0. 45 divided by 5 is 9, and 60 divided by 5 is 12. But then 9 and 12 both divide by 3, so I'll do another stage. 9 divided by 3 is 3. 12 divided by 3 is 4. So 45 over 60 cancels down to 9/12, which in turn cancels down to 3/4. If you'd spotted that 45 and 60 each divide by 15, then you could have got to the end answer all in one stage. But as you can see, it doesn't matter whether you do it in 1 stage or 2 stages or more than 2 stages, we all get the same answer in the end. So just any number that both top and bottom will divide by, that's what to do. And that's cancelling down fractions. It doesn't actually get any worse than that. It might just feel worse if the numbers involved are larger and seem more complicated, but the method you use never differs. So if we do e.g. 450 over 702. That might seem worse because the numbers are quite large, but we can do exactly the same sorts of things that we were doing before. So in this case, both of these are even, so I can definitely divide each of them by 2. And if I divide that one by 2, I'm going to get 225. And if I divide that one by 2, I'm going to get 351. And if you didn't know that off the top of your head, then you could set it off bus stop style off to one side. So that's another reason why it's important to be able to confidently divide without a calculator. Then at that point, it's not immediately obvious what each of those numbers divides by because now they're both odd, so they definitely don't divide by 2. But if I look at the digits and apply the digits test that we learned about in the prime factors video, 2 plus 2 plus 5 equals 9. And 3 plus 5 plus 1 equals 9 as well. So I know just by inspection that both of those numbers definitely divide by 9. So what I can now do is I can divide the top and the bottom by 9. Now I don't know these in my head, so I'm going to say 9 into 225. 9 into 2 doesn't go, remains a 2. 9 into 22 goes twice, 918, with 4 leftovers, and 9 into 45 goes 5 times. So the top part is going to be 25. Then I have to put 9s into 351 as well, which again I'll set off to one side. So 9 into 3 doesn't go. 9 into 35 goes 3 times, remains at 8. And 9 into 81 goes 9 times. So I have 25 over 39. And at that point then, I can stop because there's nothing that both top and bottom divide by. They definitely don't divide by 2 because they're odd. They don't divide by 3 because 25 isn't in the 3 times table. They don't divide by 4 because they're odd. 39 doesn't divide by 5. So even though 29 does, I can't have that. And if I check through a few times tables, I'll soon find that there's nothing that they both divide by. So that is my final answer. But no matter how large the numbers are, cancelling fractions down always just works the same way. You look for a number that both top and bottom divide by, and you divide by it, and then you see if what you've got divides by anything else, top and bottom. And that's cancelling down fractions. So what I'm going to do is I'm going to put back on screen the cancelling down fractions questions that I showed a few minutes ago, and now hopefully you'll be able to do them. So hit pause and have a go, and then when you've done them, hit play, and I'll put another sheet up with the solutions. All right, and I will see you in the next video where we'll be doing adding and subtracting of fractions.